Lesson today is on scatter plots and lines of best fit or lines of fit. We have three different types of scatter plots. We have a positive correlation, a negative correlation, and no correlation. A positive correlation, if we're looking at like the first quadrant in XY, we're going to focus in on this quadrant right here. This is the first quadrant. If your points look something like this, they're going in that positive slope direction, then it's called a positive correlation. It's not all fitting on one exact line, but it's a group of lines that look like it's going in the same direction a positive slope would go. Next one we're going to look at, again in that first quadrant, is a negative correlation. And a negative correlation looks like a negative slope. It has a group of lines. Again, it's not making one solid line, but there are points that are going in that direction there. So this would be a positive correlation because it's going in the direction of a positive slope. This is a negative correlation because it's going in the direction of a negative slope. And our last one here would be no correlation, meaning it doesn't have anything going on. It's just all over the place, no data that's supporting it. So it's all over. In each situation, tell whether a correlation is likely. Sometimes that correlation is not likely, so we have a no correlation. If so, then we've got to explain our reasoning behind whether it's positive, negative, or no correlation. So the number of loaves of bread baked and the amount of flour used. Well, if you think of it this way, do you need flour to make bread? And the answer is yes, we need it. Well, if you only have a little bit of flour, then you can only make a little bit of bread. And if you have a lot of flour, the more flour you have, the more bread you could bake. That would be an example of a positive correlation. Because if I'm looking at this being my flour, and this being the bread, then the bigger this number gets, the higher I get to go here. If I only have a little bit of flour, then I can only make a little bit of bread. But if I have a lot of flour, I can make a lot of bread. So this one right here would be a positive correlation. The next one says the number of mailboxes and the number of firefighters in the city. That one actually, again, has a positive correlation because the number of mailboxes represents how many people are in the city. And the more people you have in the city, the more firefighters you need. If you think of small towns, even a town smaller than ours, then they're not going to have as many firefighters as us. But our town's kind of in the middle. We have a good amount of firefighters. And then you think of a city like, let's say, New York. New York City has a ton of mailboxes, a ton of people living there. They have a lot more firefighters than we do. So the more people you have in the town, the more firefighters you need. Positive correlation. The month a baby is born and its height. This one would have no correlation. It has no correlation because if I said all the babies born in January are going to be this tall and the kids that are born in December are going to be this tall, then it would be a positive correlation. Or vice versa, if I had January, you're going to be this tall, and December, you're going to be this short. That doesn't make any sense. It's not based on the month that you're born. So a kid born in January could be this tall, and a kid born in December could be this tall or this tall. January, it could be anywhere. So that's why it's a no correlation. When the data points all lie close to a line of fit or a trend line can model the trend. There's different ways they may call it. They may call it a line of fit. They may call it a trend line. So I want you to understand that those things are meaning the same. And we have four things that we're going to do with these questions. The first thing we're going to do is make a scatter plot. The second thing is we're going to draw on that trend line or that line of fit. Next, we're going to use 2 points to write an equation. And then the last thing we're going to do is use the line to make a prediction of something that's going to happen in the future. So these are the 4 steps we're going to follow with this question. Now, because of room, I wasn't able to fit everything about this question on this page. But there's a paragraph I could put right before this that describes what's the information on this table. And the YS is standing for years since. So it's the years since 1998. So that 1 is actually representing 1 year after 1998, which is 1999. This is representing 3 years after that year. So 3 years since 1998. The next thing down, the VERTDR, is representing the vertical drop. And these are representing the heights of roller coasters that were built in the years 1999, 2001. And these are actual roller coasters and how tall they were built. What's that first vertical drop that they have? So we're going to see if there's a trend to this, and then we're going to make a prediction about what's going to happen in the future. So the first thing we need to do is make a scatter plot. And to make a scatter plot, we have to look at what's the smallest number and what's the largest number that we have here. So these are going to be my x values, because anytime you have something dealing with time, it's your x value, and your y value is the other one. This is representing that first quadrant. So again, if you have a quadrant, we're just working with this one, because we're not going to go into negative numbers. My x value, the smallest number is 1, the biggest number is 15. So on my x line, I need numbers that go from 1 to 15. If I count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it only goes to 11. So I can't use counting by ones. Just like on this line, if I count to 400, I don't want to draw 400 lines. So what I'm going to do is I'm going to count by 2s on this line to make everything fit. You want to be able to spread these numbers out as much as possible, but you also need it to fit on your graph. So I'm doing every line on my x is going to be representing 2. On my y, again, if I do that, it's not going to work. The lowest number I have is 150. The biggest number I have is 400. So if I only have this amount of lines, again, I want to spread it out as much as possible. If I count by hundreds, I'm only going to get to here. So I'm wasting all of this graph area. And I don't want to waste room. I want to spread it out. So let's see. Well, my smallest number is 151. So let's think 150. What we can do, if we want to get rid of all those numbers in between, we make this little zigzag line. And that zigzag line scrunches everything together, which allows us to start at any random number, so 150. Then again, you want to spread it out as much as possible. And what I've done with this graph is allowed every 25. And we're able to fit all those numbers on the graph, and they're spread out as much as possible. You have to spread these out in the same increments for each line. You can't just use 151 and 155 and 225 as the numbers here. You have to spread these out in the same increments in between each number. These all have to be separated by like 25 or 2 or 5. They all have to be separated by the same amount. That is actually step 1. We're still working on that, making the scatter plot. Still making the scatter plot, we're going to take all these numbers up here and graph them on the graph. So 151, we go over to 1, up to 151. And you're going to be close with some of these, you're going to be off a little bit. 3, 155, over to 3, up to 155, so it's a little bit higher there. 2, 225, 5, 225, be right here. 8, 230. 12, 306. 12, 300. So we have another one that's on 12, and that can happen, 12 and 300, so they're right on top of each other here. Could we build 2 roller coasters in the same year? Absolutely, that can happen, and we're skipping some years also. There's a 3rd roller coaster built in this year. It's at 255, which is down here. 13, 255, so same height the next year. And then 15, 400, so that last year is when our tallest one was built. So you can kind of see that positive correlation going on. We have it going in that positive direction. Next, what we need to do is step 2 of that list of 4 things we have to do, and that's make a trend line. Making a trend line or line of best fit, what you're trying to do is make a line that goes kind of in the middle of everything, but it also has to go through 2 dots. So if we're trying to make a trend line here, you wouldn't want it to go through those 2 dots. Even those 2 dots is not good. You can see how all the points are above the line and nothing's below it. You want this line that you're drawing in to go through 2 points, but you also kind of want it in the middle to represent what's going on. But even this, let's see, this is going through, and it's going through 2 points. But see how these points are really far away? We want it to go in this direction here, going through 2 points. So let's try, maybe if we go through this first point here, what did I pick? I picked to go through the first one and this 300 one. Those 2 right there. You want to extend it off your graph. So what's happening is I'm actually picking this point right here and this point right here to go through. This one and the 300 one. Now we may not pick the same points, and that's okay. As long as it's going somewhere in the middle, it's going in that direction of everything that's going up, you just are kind of getting an estimate. So that's drawing a trend line. Step 3, use 2 points to write an equation. So we picked our 2 points that we went through. We're going to use those 2 points to write an equation. Now in order to write an equation, we need a slope or a y-intercept or points. So we need slope. Let's focus there first. First we're going to find slope. y2 minus y1 over x2 minus x1. Well, here's my x and here's my y. So this is my first point. And here's my x and here's my y, and this is the second point. So what we're going to do is substitute those numbers in to our equation. And we're going to get 300 minus 151 over 12 minus 1. That gives us 149 over 11. And in this case, we don't want to deal with a lot of fractions. We need some estimations. So we're going to go ahead and make it a decimal. Because as a decimal, it's going to be easier to work with. And again, we don't need exact things. So we have a slope. We have some points, a point and a slope. We're going to use point, slope, form. Point, slope, form. And we're going to use that information and plug it into this equation. So y minus my y1 number is 151 equal to my slope of 13.5, x minus my x1 number, which is 1. Solve for y. So to solve for y, we're going to distribute. And get the y by itself, so we're going to add 151 on both sides. So this part of it is all review of stuff that we've already done. We're finding our slope. We're solving for y. And we now have an equation in slope-intercept form. Now that we have it in slope-intercept form, we can now take that information and make a prediction about what's going to happen in the future. So a question I could pose to you is, what would be the height, if this trend continues, what would be the height of a roller coaster built, let's say 25 years after 1998? So 25 years after 1998, so my x value would be 25. Years since 1998, 25. That means I'm going to take this equation I've just solved. I'm now going to put a 25 in place of x, because my x value, my years since 1998, is going to be 25. And if this trend continues, we can make a prediction about what the height of a roller coaster will be in that year. Now, there is going to be a time where we can't build them any higher, right? So this is just saying, if this continues, what would it be? And that roller coaster would be 475 feet tall.